Well, hi there. Welcome back to Chapter 11. We're going to be looking at the relationship between pressure and temperature. So, as you can imagine, temperature is really just a measure of the kinetic energy of matter. And gas pressure is a result of collisions of the molecules with container walls. So, as the temperature goes up, the kinetic energy, the average kinetic energy, also goes up, and therefore the frequency of collisions goes up and the pressure goes up as long as the volume stays the same. So you go, well, wait a minute, how's the volume going to stay the same? You have to have a rigid container of some sort. You have to have a glass container, a steel container. You could have a gas cylinder like they do in hospitals, or a submarine, something along that line. So if the volume doesn't change, then the pressure will go up with an increase in temperature. Don't forget that the temperature has to be in Kelvin. To get Kelvin from Celsius, you add the number 273.15. We rounded up to 273, close enough. So here we have a direct relationship between pressure and temperature. This law is named after Joseph Gay-Lussac, who discovered it in 1802, and once again, it seems like yesterday. Mathematically, here we go again. Mathematically, we got P equals KT, or P over T is equal to K, the one I like. Don't forget, P is the pressure, it can be in any units. T has to be in Kelvin. The form that we're really going to be using, this one, P1 divided by T1 is equal to P2 divided by T2. So the initial conditions of pressure and temperature, take pressure divided by temperature, will be equal to the final pressure and temperature, pressure divided by temperature again. So once again, you have four variables. If you have three, you should be able to solve for one of them. You have to remember, of course, that this only works if the volume is held constant somehow and that the temperature is in Kelvin. Looking at a sample problem. Well, here we go. The gas in a container is at 3 atmospheres and 25 degrees. We're going to warm this container up, but not to go over 52 degrees. Okay. What would the gas pressure be if we went to 52 degrees? So here we have a container that is not going to change size. Its volume will remain constant. And the first thing I'm going to do is I'm going to take that 25 degrees C and that 52 degrees C. I'm going to add 273 to both of them and change them to Kelvin immediately before I do anything else. And now we have an initial pressure of 3 atmospheres. We have a initial temperature of 298 Kelvin. We have a final temperature of 325 Kelvin. And now we will take and we'll do what we call plug and chug. We'll take the variables we've got, the P1, T1, T2, we'll put them where they belong. And we'll put them where they belong, and we will solve for P2. So we'll cross multiply P1 times T2, and then P2 times T1, and then we'll divide both sides by T1, and we will get 3.27 atmospheres. Bada bing, we're done. A nice, easy problem. And don't forget that the units for your answer will be the same units that you used in the problem. So if you use atmosphere in the problem, you're going to get atmosphere in your answer. That's it. This is a summary of the basic gas laws. So far over the last couple of weeks, we've looked at Boyle's law, we've looked at Charles's law, and we've looked at this law, Gay-Lussac's law, and then Avogadro's law. Avogadro's law, we're going to get to that in a roundabout way. Right now, we're only going to look at the first three. There's one more that we need to look at, the combined gas law. This, of course, is my favorite because you don't have to remember the three laws individually. You can take Boyle's law, and Charles's law and Gay-Lussac's law and mathematically put them into one equation. For situations where temperature, pressure, and volume all change at the same time. Which, let's face it, that's what happens in real life. The combined gas law actually gives you the formula for the relationship between pressure, volume, and temperature. And it can be, you look at it as follows: PV over T. Just like the other ones, we've got the initial conditions of PV over T are equal to the second conditions of PV over T. And we're going to look at PV over T when we come back at the next set of slides. So what you need to do now is go get the worksheet that's online. You have a bunch of solutions you're going to have to calculate. Check your answers off the answer sheet. Watch the video I put up from Ed Puzzle. Take the practice quiz from Quizzes. Take the real quiz sometimes at the end of the week. And if you need help, come and visit me Tuesday, Thursday, or Friday. I'm sending out invitations to office hours all the time. If you need me other than that, by all means, let me know, and I'll be delighted to get together with you anytime you want. That's about it. Have fun.